In this video, we are going to review our metric units, and I will teach you a new method to use to convert units. And this is the method that we will use throughout the year, and this is called dimensional analysis. Now, as you know, in the US, we use English units, and we are one of the 3 countries that still uses English units. The rest of the world uses metric units. So we use Fahrenheit, while the rest of the world uses Celsius. We use foot, inch, mile, while the rest of the world uses meters and kilometers and centimeters. We use gallon and pint, while the rest of the world uses liters. And we talk about pounds, or we use pounds, while the rest of the world uses grams or kilograms. For example, if you run, you have probably run a 5K or a 10K before. And we even say we're running a 5K or we're running a 10K. And what does that actually mean? A 5K is equivalent to 3.1 miles, and a 10K is equivalent to 6.2 miles. But whoever remembers the miles, right? We just say that we're running a 5K as opposed to, yeah, I'm going to go out and run 3.1 miles, right? I know that in other parts of the world, their height is measured in centimeters, while ours is feet and inches. And so in science, because we are communicating with the rest of the world, and scientists are communicating with other scientists from different countries, we want to make sure that our units are the same. And so we also use metric units in science. So these are called SI units, Standard International Units, and you've learned this probably in elementary school and middle school, right? King Henry died by drinking chocolate milk. And each letter stands for something. King is kilo, Henry is hecto, died is deca, you have your base unit, by, drink is deci, chocolate is centi, milk is milli. And the way that you use this mnemonic device in terms of converting your numbers from one unit to another is you probably just move your decimal over to the right and you move your decimal over however many spaces to the left, right? Well, that's not exactly what we're going to do here today. We are focusing on these 3 units, meter, gram, and liter. And we're actually just going to focus on the centi, the milli, and the kilo. So when it comes to mass, we're talking about grams. Grams is our base unit. So let's go over some of these relationships, okay, which will lead into our conversion factors. There are 100 centigrams in 1 gram. There are 100 centigrams in 1 gram. There are 1,000 milligrams in 1 gram. There are 1,000 grams in 1 kilogram. What about distance, where meter is the base unit? How many centimeters are there in a meter? 100, because centi, right? The word centi, 100 centimeters in 1 meter. There are 1,000 millimeters in 1 meter. There are 1,000 meters in 1 kilometer. And what about liter for volume? Again, centiliter, 100 centiliters in 1 liter, 1,000 milliliters in 1 liter, and 1,000 liters in 1 kiloliter. When it comes to amount, and we'll talk more about this in the next video, we're talking about moles. So this has to do with amount of atoms, amount of molecules. Mole is our base unit for that, which again we'll come back to next in the next video. So let's do these problems real quick, and this is just to refresh your memory on moving the decimal place over to the left or over to the right. And we're not going to do this. We're actually going to convert this using what we call dimensional analysis, which I will cover in a little bit. But if we have 480 centimeters and we want to convert it to meters, well, how many times do we move the decimal over to the left? 1, 2 times, right? So you pretend that the decimal is out here, you move it over to the left twice, and you have 4.80 meters. What about 75 milliliters to liters? Well, you're at milliliter. You're going to move it over 1, 2, 3 times, so you have 0.075 liters. So you probably remember doing this back in middle school or elementary school. Take a few seconds to go through these problems on your own. Play the video when you're ready. So these are the answers you should have gotten. Now, I want you to go ahead and throw out this decimal moving method because we are going to convert these units using dimensional analysis, which I will cover in just a few minutes. But first, let's review scientific notation. Scientific notation, if you don't remember, has a base number times 10 to the any number. Okay? So we usually use scientific notation to represent very large numbers or very small numbers, like 0.00000000502. Right? We don't want to write all those zeros, nor do we want to count all those zeros. So we want to go ahead and condense that number, and we use scientific notation to represent that small number. And again, we do the same thing for a large number. So keep in mind that when you move the decimal to the left, the exponent will be positive. So for example, let's say that I want to change this number, 1,000 meters, to represent a smaller number. So I'm going to convert it to scientific notation. So you pretend, if there's no decimal here, you pretend that there's a decimal out here, and you're going to move it over until you have one number to the left of the decimal. One and only one number. Okay? And it has to be a non-zero number. Okay? So that means anything greater than 0. So 1 through 9. So again, decimal, move it over to the left. How many times did we move it over? We moved it over 3 times, and that 3 is going to represent our exponent, so we say 1 times 10 to the 3 meters. How about this one? This one is already in scientific notation, however, it's not in proper scientific notation. Remember what I said just a few seconds ago, you only want one number to the left of the decimal. So we take 175, and we move the decimal over how many times? 1, 2. We move it over 2 times. Now take a look at the rule. What happens to the decimal when you move it over to the left? It becomes positive. So we moved it over to the left twice. So what we do here is we're actually going to add 2 to the exponent. And so our new number is 1.75 times 10 to the negative 13 meters. And that's just rewriting our scientific notation number into proper scientific notation. Now what happens if you move the decimal to the right? Then the exponent will be negative. So this has to do with really small numbers. So the density of air at sea level is about 0.0012 grams per centimeters cubed. Well, I know that this number isn't too small, but let's say that we want to convert this number into scientific notation. So the decimal is already here, it's present right here. So we're going to move the decimal over to the right until we only have one non-zero number to the left. So how many times do we move that over? 3 times. So our number can be rewritten as 1.2 times 10 to the negative 3. Notice that it's a negative exponent because we move the decimal to the right. So let's practice with this. And let's practice writing this with just 3 numbers. Okay? So let's go over the first one. It's a big number. There's no decimal there, so we're actually going to start out here. So how many times are we going to move it over? 1, 2, 3, 4, 5, 6. So how would you rewrite that number? 9.32 times 10 to the 6. And this is what I mean by 3 numbers. These are just the 3 numbers that I want to see. Okay? What about the next one? The decimal is already there, so we want to now move it over to the right. 1, 2, 3, 4. So we have 2.49 times 10 to the -4, right? How about the next one? It's already in scientific notation. However, we want to put it in the correct scientific notation form. So 1, 2, 3, 4, 5 times. So this one already has an exponent, and we move the decimal over to the right. So instead of adding, we're actually going to subtract 5, right? So what's -4 or -4 minus 5? 10 to the -9. So this would be 4.39 times 10 to the -9. And the reason why that 9 is there is because all I did was that 6 rounded up my 8, right? Because I just wanted 3 numbers, okay? And the reason why we went over scientific notation is because when we are dealing with kilo or milli, sometimes the numbers are big, sometimes the numbers are small. So we want to know how to convert these numbers so that they are in proper scientific notation. So now let's take a look at converting units by using dimensional analysis. Dimensional analysis is also called the fence. If you watch other YouTube videos, they might call it a T-chart. I tend to call it the fence. So dimensional analysis is just a method that we use to convert units, and I'm using it now in this intro video with units that you are familiar with, right? You have heard centimeters and meters before. You have heard kilometers and meters before. So we're just using familiar words and using that to first learn the method of dimensional analysis. Now, this is a method that we will be using throughout the year. So please use this method. Please practice this method. So these are the steps for the fence. You do have it on your notes to refer back to it. I will take you step by step on how to use the fence. Let's first start with example number 1. How many liters are in 2,500 milliliters? Now, this right here, what you see is the fence. So it's just a line down and a line across. We start in the top left corner of the fence, and we start with our given number. So what is our given number? It is 2,500 milliliters. So I write 2,500 milliliters in the top left corner. Now, before I do anything else, I'm going to pause here, and we need to think about the relationship between liters and milliliters. And we just went over it, right? And I'm not talking about how many times you're moving the decimal over to the right or to the left. I'm talking about, what is that sentence we said? How many milliliters are in 1 liter? We talked about in 1 liter, there are 1,000 milliliters. This right here is the relationship. This right here is actually the conversion factor. So I can actually rewrite this as a fraction or a ratio, right? Because that's exactly what this is. So I'm going to put it up here on top of your screen. I can write this as 1 liter is equal to 1,000 milliliters. I can also show this as this 1,000 milliliters is equal to 1 liter. Again, this is more of a ratio. I'm not telling you to divide right now. So we're using one of these to plug in to our fence down here. Okay, now how do you know which one to use? Well, let's continue with our steps. We're going to bring down the unit that we started with. So we have milliliters. We're going to bring it down to the bottom of the fence, and we're going to write milliliters down here. Now take a look back on top of the screen. Which one has milliliters on the bottom? This one, right? So I'm actually going to write this into my fence. So milliliters, on top I'll write liters, and I always write the units first because I want to make sure that the units are in the right place. If the units are not in the right place, then your numbers will not be in the right place. If your units are in the right place, then you can't go wrong with your numbers. So now that I have liters and milliliters, I'm going to write 1 on top. I'm literally just transferring this number down here. And then with milliliters, you see how I wrote 1,000. So again, I'm just going to copy that and write 1,000. And this way, my like units cancel each other out. Okay? And the way that you solve for this is you multiply across and you divide by whatever's on the bottom. So this is essentially what you have. 2,500 times 1 divided by 1,000. If I put the units in here, and I know I'm taking a little bit longer to explain the very first one, this is like your Algebra 1 class, right? Like units will cancel each other out, and that's why I had canceled it out in the fence. So what are we left with? We're left with liters. What is the question asking for? The question is asking for liters. Okay? So plug that into your calculator. What is 2,500 divided by 1,000? That is equal to 2.5. And remember, no naked numbers, so 2.5 liters. Let's try another one. How many milligrams are in 62 grams? Well, we draw the fence. Where do we start? We start in the top left corner with what we're given, so 62 grams. Now what? Well, we want to think about the relationship between milligrams and grams, right? So, what is the relationship? Well, we have 1,000 grams is equal to 1 gram, okay? So, here's our starting point. This fence is our starting point. This fence over here is our conversion factor. So, what do? We bring down the unit, the same unit, and only the unit. I don't care about the number. So I bring down grams. Okay? So I look at my conversion factor. I'm going to look at two different, oops, that should have said milligrams. So I'm going to look at two different ways I can write this. I'm either going to write it like this, or I'm going to write it like this. Which one do I want to plug into the fence? The one where the G is on the bottom, the grams is on the bottom. So on the other side, I'm going to write milligrams. What number goes with milligrams? 1,000. What number goes with grams? 1. Like units cancel out. 62 times 1,000 divided by 1 is equal to 62,000 milligrams. Can you convert that to proper scientific notation? Yes, you can. So you can write 6.2 times 10 to the 4 milligrams. How about number 3? How many meters are in 8,072 centimeters? So we're going to start with our given number. I always write the number first and then create the fence. And then I want to think about the relationship between meters and centimeters. So in 1 meter, there are 100 centimeters. Okay? So we're going to copy down our unit, centimeter. And again, if it helps you to write it as a ratio, please do so. So which one will I use for the fence? Right, I'm going to use this one because I want to match up the units. So I'm going to write 1 on top, 100 on the bottom. Go ahead and solve. So it's 8072 times 1 divided by 100 is equal to 80.72 meters. Go ahead and try the next one on your own. Go ahead and play the video when you're ready. And this is what your setup should look like, and you should get an answer of 1.09 times 10 to the negative 4 kilograms. Let's take a look at a unique problem, number 5. Calculate the mass of an object that has a density of 0.863 grams per milliliter and a volume of 5.50 milliliters. Now, this is a density problem, and previously, I know you've done density in biology. Density is mass divided by volume. And we also looked at density problems earlier this year. Well, we're actually not going to use the formula, but I want to use the fence to show you how to plug in this problem. Because let's pretend that we don't know the formula for density, okay? But this is, again, it's another it's another unit conversion problem. So what we do is we're actually going to start with the value of 5.50 milliliters. Why that number? If you take a look at the density, you see how it's grams over milliliters? Well, you know how else this can be rewritten as? It can be rewritten as 0.863 grams in 1 milliliter, right? If I write it as a fraction as we've been doing, I can show it like this, over 1 milliliter, or I can also show it like this. Okay, again, just looking at it purely as a ratio form. So knowing that I'm starting my number with milliliters and I'm going to copy down milliliters, which one of these am I going to want to use? Right, the very first one. So let's go ahead and write that in. 1 on the bottom and 0.863 grams on top. My milliliters will cancel out. I'm going to go ahead and solve the problem, and the mass is 4.75 grams. You see, I didn't even need to know the density formula. Go ahead and try this one out on your own. Remember, never begin your fence with the number where it has one unit over another. Remember that this could be used as a conversion factor. Go ahead and play the video when you're ready. Did you get an answer of 5.33 milliliters? Great job if you did. Did you also set it up the correct way? Great job if you did. So this is how I set it up. I did use this conversion factor here because my grams should be on the bottom, and so that's what I plugged into this fence, and then I multiply across, divide by whatever's on the bottom, and I get 5.33 milliliters.